Today we're going to learn the law of cosines. Just to review what we learned the other day, if we're given angle, angle, side, or angle, side, angle, we're going to use the law of sines. Then we learned about that special case where if we have side, side, angle, we still are going to use the law of sines, but we have to check for that second triangle. Today we're going to learn if we're given side, angle, side, or side, 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 then we have to use the law of cosines. The law of cosines will work for any triangle, and we could use it all the time if we wanted to. So notice the law of cosines isn't quite as easy as law of sines because it has a lot more letters and things involved in the formula. So that's why we usually use the law of cosines just once, and then we go back and do the law of sines with the rest of it. So in these notes, I'm just going to show you how to find first of all, what the formulas are, and then how to find it. And then after that, you're just going to do the rest of the pieces that you're trying to find using the law of sines. So we're still trying to find, if it's not a right triangle, we're still trying to find what all the sides are going to be and what all the angles. So for example, if I start with side, side, side. If I'm given three sides of a triangle and it's not a right triangle, then I know I'm going to have to find an angle to start with. So we find an angle. This is called the law of cosines after all. So we're going to start off with the cosine, and I'm just going to choose letter C. So the formula looks like this. You take the two sides that make up angle C. So in this case, it would be side A and side B. And you square those and add them together. So it's going to be A squared plus B squared. And then you subtract the opposite side. So the opposite side is C, so I'm going to subtract C squared. So these two are my adjacent sides, and this one is my opposite side. And then I'm going to divide all of that by 2 times the adjacent sides. So I'm going to end up with 2AB on the bottom. Now, kind of like we did when we found the area of our triangles the other day, we can notice a pattern here, and we can use that pattern to find another version. So let's say I had the cosine of A. It would be equal to, I would have to add up the other two sides. So that would be my B squared plus my C squared. And then I'm going to subtract that opposite side, which is A squared. All over, I'm going to divide by 2 times B times C. So again, notice the pattern. Okay, if what I'm trying to find is angle A, then I use the other two that I haven't used to add them together, and then I subtract what that opposite side is. So then there would also be a third one. If I wanted the cosine of B, it would be equal to A squared plus C squared minus B squared all over 2 times AC. Now again, I don't really memorize the formula itself as much as I memorize the pattern so that I can recreate that on my own without having to have it memorized. And I'll do that when we do an example in a minute. Then the other example is when you're given side, angle, side. When you're given side, angle, side, you're trying to find another side. So if I wanted to find C, for example, you start off with C squared, and then you take the other two sides and you add them together, squared. So A squared plus B squared. These two are the other sides, not the one I'm trying to find. Obviously, they're the ones that's given. And then you're going to subtract 2 times the AB, and then you're going to multiply that times the cosine of the C, because C is the angle the side that I'm trying to find. So that's the opposite from the side. I want to find that angle. So I could again make another version of this. If I wanted to do A squared, for example, the other two sides would be B squared plus C squared minus 2, and I'm going to repeat those letters again, B and C, and then the cosine of A, because that's what I'm trying to find. And the last one, which I could write, would be B squared. And B squared, of course, would be A squared plus C squared. And then minus 2 times AC cosine of B. So it seems like a lot to remember. It seems like it's really long. But once you start doing it, it starts making sense. And you really don't, like I say, have to memorize it if you know the pattern. So let's look at an example. So the first thing we're going to do is label our triangle. And so they gave us that angle B was 35 degrees, and A was 5, C was 6, and they're asking me to find my lowercase b right here. So notice that they've given me side, angle, side. So this is what they've given me. And notice if I tried to do it with the law of sines, I'd put sine of 35 over b equals the sine of, oh, I don't have another angle to use, do I? So that's why you can't use the law of sines. If you tried to use the law of sines, it wouldn't work. So you're going to realize I got to use something else. So I'm going to use the law of cosines. So since it's the side I'm trying to find, remember we start off with it squared. B squared equals, and then you take the other two letters. Okay, so the other two letters are A, so I'm going to put A squared plus C squared, and then we subtract 2 times that AB, and then we multiply it times the cosine. Uh-oh, I made a mistake. This should have been what? AC, right? And then the cosine of B. So now I'm just going to plug in the letters. So B squared is going to be equal to, A was 5, so I'm going to put 5 squared, plus C was 6, so I put 6 squared, minus 2 times 5, because A is 5, times 6, because C is 6, and then the cosine of 35, because that's the angle that I know, 35 degrees. So now to get my answer, I'm just going to plug all of that in my calculator. So I'm going to plug in 5 squared plus 6 squared minus 2 times 5 times 6 cosine of 35. Do I have to worry about what my mode is on my calculator? Yes, because I'm entering a cosine, right? And so I get 11.85087. So if I wanted to round at this point, I would round to 11.851. Now I'm not going to be real picky about rounding in this section, so you could do this and that would be fine. But the best way to do it would be, now I need to find the square root of that to actually get b, right? So I can put in the square root, and then if I press second and the negative sign, it puts that little answer there. It'll put my whole number without any rounding. And then I hit enter, and my final answer will be 3.443. Because remember, we're going to round it to the nearest 3 decimal places. And notice that if I had just done the square root of 11.851 and gotten my answer, it would still be 3.443. So I'm not going to be as picky on rounding, so you don't have to worry about it as long as your work is leading the right way. And realize that now, once I know this side is 3.443, I can go ahead and use the law of sines to find my other two angles. So once you find one, you can find the others just by using the law of sines. So let's look at another example. Label your triangle. So A is 5, and B is 5, and C is 6. So this time we're given side, 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 and the question is asking me to find angle A. So I'm going to start with the cosine of A, and then remember this formula was where we take the two that make up angle A. So the two that make up angle A are 5 squared plus 6 squared, and then we're going to subtract the one that is across from the angle, so we're going to subtract 5 squared, and it's going to be all over 2 times 5 times 6. Remember, we're just multiplying those first two numbers and then multiplying it by 2 on the bottom. Now it works best if you just go ahead and write that as a fraction, not even worrying about simplifying it, but just doing 5 squared plus 6 squared minus 5 squared. And of course, you're going to end up with 36. And then 2 times 5 is 10, times 6 is 60. So I end up with 36 over 60. Now since it's an angle I'm trying to find, I'm going to put A is going to be equal to, I have to take the inverse. So the inverse of cosine of 36 over 60. So I'm going to put in my calculator second cosine of 36 divided by 60, and I get 53 degrees. And then once I have that angle, then I can go on and use the law of sines to find my other two angles.